In this problem, we also have a package or a box, but in this case, we are looking at a mailing tube. All right, so I apologize for my lousy picture. It's, one of these though, right? I don't know what's in there. But anyway, if you read it, it says a package to be mailed by the U.S. Postal Service may not measure more than 108 inches in length plus girth. So that's a package of any shape, not just the tube, right? But so what they do is they define length as the longest dimension and then girth as the thickest part of it perpendicular to the length. So that allows them to define this for packages which are of, odd lumpy shapes or whatever. Okay? And so those two dimensions, the length, in this case, it's just the length, like the height of the cylinder, and the girth being the distance around is just going to be the circumference, right, of the cylinder. So that's the idea. But those two dimensions cannot be more than 108 inches in length. So the problem asks us to find the dimensions of the mailing tube of largest possible volume. Because of course you can imagine it can be short and fat, it can be long and thin, but the issue, or rather the constraint, is that those two dimensions, the length plus the girth, cannot be more than 108. So I pulled this problem from the book. They didn't give you the picture, so I wouldn't expect you to be able to, you can probably figure it out, but it's always nice to have a picture to help understand, okay, this is what they mean by length and girth and whatever, right? So I do try to give a picture when it's something that's a little bit perhaps more unusual. In any case, the picture that I want to use though, I'm going to redo this just a little bit to make it look more like a cylinder, right? So our standard cylinder looks like this, of course, and we usually use height H and radius R, right? And what's the volume of a cylinder? Volume of the cylinder is pi r squared h, right? Because we are going to take the area of the circle and multiply it up through the height. Okay? So that's our volume. And now let's see, what else are we going to do? We need to find the maximum volume, right? So we want to take the derivative of this, our height and our radius, and we have to figure out how to get the relationship between them. So the girth here is going to be the distance around, right? So girth is going to be 2 pi r. That's just going to be the circumference of the circle. And then the length is going to just be our h. So what this means is that we have 108 equals h plus 2 pi r. So that is our constraint. So I can eliminate whichever one I want. You know what? I'm going to solve for h, right? Because then I don't have to have something square, or just the r squared. So I'm going to solve for h. From this constraint, I'm going to get the h is 108 minus 2 pi r. Once I have that, then I can plug this into this, because what I'm going to do, right, is maximize the volume. Okay, so this is 108, so that in there, so I got volume equals pi r squared times 108 minus 2 pi r. So this is a pretty nice looking thing. 108 pi r squared minus 2 pi squared r cubed. I'm going to take the derivative of this. All right, let me perhaps, we'll just go with it here, see what we can do. So the derivative is going to be, 108 times 2, so 216 pi r minus 6 pi pi squared r squared. Okay? So this we have to set equal to 0. Well, clearly r equals 0, right? That's going to be one possibility. Let me kind of pull this over here. How many times does 6 go into 216? Who knows? 3, 8, is 36 times. Look. Okay, so what I have, if I pull out a 6 pi, I have 36r minus pi. No, I want, all right, fine. I wanted to pull out one with an r too. So let's do that again. 6 pi r, 36 minus pi r equals 0. Okay, so r equals 0, which is clearly going to be a minimum, right? Because there's going to be 0 volume. Or r equals 36 over pi. Okay? So we can check to make sure that the 36 over pi is going to maximize my volume by let's taking a look over here. If I put in something small, like 1, okay, let's see, if I put in 1 here, I've got, wait a minute, what do I do? That doesn't look right, does it? Because if I put in 1 here, I'm getting something that's, oh yeah, that's right, it's positive, right? Okay. Put in 1 here, I get something that's positive, right? If I put in something really big, like 36, right, then it's going to be negative. All right, that's right, there we go. So that is right, that's going to be my maximum. Okay. And then 0 is going to be a minimum. I'm not really worried about anything less than 0 because it doesn't make sense for the problem. So then what is the question? Since I've found my minimum, I found my minimum r. So it asks you for the dimensions. Okay, so then I just go back. So I have r equals 36 over pi, and it's in inches because the original thing was in inches. So it asks you for both dimensions, right? So I know r, I can find h, which is right here, right? So I'm just going to plug that into here. H equals 108 minus 2 pi times 36 over pi. So 108 minus 72. I'm going to say it's not 72. It's 108 minus 72 is not 72. All right. 36, right? Okay, 36 inches. All right, there you have it. Those are the dimensions. If they asked you for the volume, then you could plug that stuff back in here and find the maximum volume in cubic inches. But they didn't ask, so I'm going to do it